Hello everybody and welcome back to the MFX Modules series, a collection of micro setups for those who want to get their knowledge on. As always, support is much appreciated. Please like, subscribe, and check the video description for links to relevant project files. In this first video, Module 1, we're going to cover the mapped transition, which is how we can build a normalized slider that can be used to comb a mask through any attribute and drive all sorts of cool effects. So let's dive in and check it out. All right, so here I am in a fresh scene of Houdini, and to start, let's just throw down some geo. So I'm going to throw down a geo node, and we'll dive inside and throw down a grid. And I'll just frame that up here. And let's add some rows and columns. I'm going to add set my rows to 100 and my columns to 100. So we got some more resolution to work with here. Next, I need to create a normalized attribute that maps across our geometry that will provide a map as to where the start and end of our transition is going to be. So I want that map to be ranged from 0 to 1, so from 0% to 100% of our transition, for example. And the way that I like to do that, that's the easiest to do that, in my opinion, is to use the distance along geometry node. It's a fancy node that will actually give us a normalized distance from the start point to wherever the furthest distance in our geometry is away from that start point. So I'm going to throw down distance along geometry, wire that in here, and I'm just going to select some start points. So if I go over here and select this little picker and maybe pick this point all the way on the left-hand side of my square and hit enter, you can see that it enters point 9900 into this group field here. And now it is outputting a distance attribute. And if I look at my geometry spreadsheet, you can see that this distance attribute ranges from 0 all the way up to 14. So what that's giving us is the real world distance. If we click this little button right here, we can kind of visualize that and turn on my visualizers here. You can see that it's visualizing that attribute kind of as we move away, we get higher and higher values in our distance attribute. So this is working as expected, but it's not giving us a normalized attribute. A value that goes from 0 to 14 in terms of meters is a little bit more than what we want. We want to actually have this be normalized from 0 to 1. So thankfully, there's an extra little section inside of this distance along geometry node that gives us that normalized attribute. So if I actually untick distance and turn on output mask, what we can do is set our radius from a parameter. Now I'm going to go and let's just hit the info key here and visualize the mask. By default, you can see that we can set a radius. We can just crank this up if we want, or we can set our radius from, so that's setting our radius from a parameter. We can actually set it from maximum distance. And what it'll do is it'll actually measure where the furthest distance is and do a normalization for us. Now, if we look at our geometry spreadsheet and look at this mask attribute, we can see that it actually goes from 0 all the way up to 1. So now we have that normalized attribute that we were looking for. It's cool. Now, if we look at this map, we can actually see that the higher values are at the start and the lower values are at the end. And that's kind of indicated here by this mask visualizer. You can see that 1 is red and purple is 0 because it's on the left-hand side of this ramp. We actually don't want that. And this is also a smooth ramp. So I'm going to just reset this to the linear mode, and that'll give us a more predictable linear transition from 0 to 1 as we move across our geometry. The next thing I'm going to do before we get carried away is actually rename this output attribute to map, because I'm going to make a differentiation here between what a mask and a map is as we move into the next section. But basically, I want this to be a map for our mask that we're going to be creating in the next node. So I'm actually going to rename this. We'll call it map. And our visualizer will go away. But if we just hover over our distance along geometry node, turn on our info, and then tap the map button, we get it back there. So we've got our two visualizers for our mask and our map. The reason I like to store the map differently or separately from the mask attribute is because it's nice to be able to swap out what your map is and have it affect your mask attribute and just be able to control them independently of one another. So we've got our map attribute now, normalized map attribute, and the next thing is to create our little transitioner. So let's throw down a point wrangle. We're going to do that in a point wrangle like so. So what I'm going to do to start this off is we're going to bring that map attribute that we created up here in and apply it to a local variable. So let's create a float map variable, and to it we will apply the f@map attribute that we created above here. The next thing that we want to do is create a couple sliders so that we can determine where we are as we're coming across this geometry and how wide of a transition we want to have. How thick should that transition area actually be? So let's create those two variables. The first one I'm going to call our position. I'm going to say float p is equal to, and we'll create a slider for that called position. So float p equals CHF position, and then the transition width is going to be another float attribute called t. And we'll set that equal to another parameter called transition width, like so. And I'll just hit this little button right here to create those those little sliders for us right here. Now let's remap this map attribute out to a mask attribute that we can use in our setup here. So I'm going to throw down a new float. So say float mask, and we're going to fit range our map attribute using this position and transition width slider that we've created here. So we're going to use the fit function. Fit function takes 5 arguments. The first one is what we want to be remapping. So we're going to remap our map attribute. Just going to put that in, and I'll add a comma. And then we need our input start and our input end as our next two parameters. So our input start is going to be wherever this position slider is. So we're going to put in P as our input minimum. And then the input maximum is going to be wherever our position plus our transition width is. So we're going to put in P plus T here for our second parameter. And then we just want to remap that to another normalized attribute, which means that we want to output a value from 0 to 1. So in our case, I'm going to put in a 0 and a 1 here for our last two parameters and close it off with a parentheses and a semicolon. So let's output this to a mask attribute. So f at mask equals mask. And now if I hit the info button here and click on mask, you can see that it's starting to output our mask, but nothing really kind of makes sense. You can kind of see that this little corner has some color to it, but if I take my position and my transition width and crank it all the way up, you can now see that we're getting back exactly what we had for our map attribute before. And that makes sense here because we're taking our map and remapping it from a value of P, which is 0, to P plus T, which is 0 plus 1, which is 1. So we're remapping a value from 0 to 1 to 0 to 1. So it's essentially doing nothing, just giving us what we had before. Now, if I bring this transition width down to, say, 0.5, you can see that it's giving us that value. It's outputting a value of 0 to 1 as we go from 0 to 0.5. So this is how we can control the width and the sharpness of our transition. And here we just are offsetting the position of where that transition is happening. So we want to have a really sharp transition. We can bring our transition width down to something very small, and this will be a very abrupt transition through our geometry. But if we want something more smooth, we can crank this up and really have it fall off nicely like that. Now at this point you might notice that we're actually transitioning from on to off, whereas I actually like to transition from off to on, meaning that our output is reversed. I want us to start with a mask value of 0 and transition to having a mask value of 1 when we're done. So we just need to reverse these last two parameters around. So I'm going to set the second to last parameter to 1 and then the last parameter to 0. And you can see that that just inverts our mask. So we're going to be going from fully unmasked to fully masked as we transition, as we move our slider like so. The next thing that I would like to have as a convenience factor is that when my position slider is at 0, I don't want there to be any transition starting to happen. And the way that our current fit range is set up is not going to be able to handle that. It actually is, it's fine if we go up here to 1 because we're adding P plus T, and since it falls out of range of 0 to 1, it just gets mapped back to 1. But we need some way to compensate for when we're at 0, we actually don't want to see any transition happening yet. And so if we actually start to crank into the negative, you can see that if we crank this all the way away, see this value is very similar. What we need to do is we need to have it so that when our slider is at 0, our slider actually evaluates to negative whatever this transition width is. See how these numbers are very similar? This is just the negative of this number right here. So what we can do is, this is where we introduce the second fit range for the double fit range to actually achieve this so that our slider works the way we want it to. The way I'm going to achieve that is actually above this mask right here. We're going to apply a fit range to our position. Now we already know that our position is a slider that's going to go from 0 to 1. So we know our input is 0, 1. So we can use actually in this case the fit 0, 1 function. So we're going to say P equals fit 0, 1, P between negative T and 1. Now if I slide, you can see when I bring this down to 0, our transition disappears, but as I start to creep up, you can see that it allows us to fully sweep across from 0 to 1, covering all of our geometry, just the way we want it. Next thing I like to have in here for convenience is just a little ramp parameter, so I can kind of control the shape of my fall off a little bit. So if I just bring this back in here to about 0.5, so we can kind of see it there. Let's set both of these values to 0.5. I'm going to put the ramp right after here. So what we're going to do is just remap mask. We're going to fit it to a ramp parameter. So ch ramp. We'll call the ramp ramp, and we're going to ramp over the mask attribute that we're currently using. And if I hit this button, we get a ramp here. So you can see we can kind of actually have a little bit of further control over the shaping of our mask if we wanted to add something a little ripply or whatever. I'm just going to set this back to a value of 0 to 1 as a good default. And then by default, I'm going to put this position back to 0 and our transition width back to 0.1. So we get sort of this transition built in by default. And then we can save this to our gallery so we have it easily accessible later on. To save it to the gallery, just right click on the node and say save to gallery. And this little window pops up here. And you get the ability to give it a name and a label and choose where you want it to be saved into your gallery. You can choose what category you want it to go into. And then that would be accessible up here in under Windows. There's a gallery manager, and you can see that I actually have a bunch of gallery presets that I've saved here. These little Vex presets, I've saved these to keep on hand for my various projects. So what I'm going to do is just rename this mapped transition. I always like to put my initials at the beginning, so the MF map transition, and I'll just call it the same thing, MF mapped transition. I'm saving this into my documents, so it's going to create a gallery folder inside my Houdini 19.5 folder, and it's called custom.gal. That's cool. I'm just going to call this tutorial.gallery file. So it's going to save it into a custom gallery file there. You can name this whatever you want. You could give it a category if you want. I could just say, this is my Vex presets, like so. I'm actually going to rename this for tutorial, so I know which one's which, because I do already have one in my library. And we'll just hit accept. Now, if I go up to my Windows Gallery Manager, I should be able to find tutorial. Under Vex presets, you can see my map transition tutorial right here in my gallery window. I could drag and drop that in here, like so. You could also throw it on a wrangle like this and access it through the gear menu. So if I tap this gear icon here and I scroll down, you can see that I have down here the map transition tutorial preset. And if I click that, you can see that it loads it up with all of our presets set like so. Real quick before we move on, I just wanted to clear up one thing that I noticed with the setup that we have currently. So if I look at my geometry here and I kind of comb across it, we can see everything's going from 0 to 1. But in the case that the transition width is set to actually 0, if we crank our position slider all the way up, you can see that for some reason, this one point doesn't actually fully resolve until the transition width is some extremely small number. It just can't be 0, probably because in the fit range calculation, there's like a divide by 0 protection happening or something like that. You can also see down here when we bring our transition position all the way down, we don't actually get it to fully clear off to nothing. So what I like to do is add a little epsilon value. Epsilon's like a term for things that are super tiny in computers. And so what we're going to do is clamp our t to a value that's just above 0 by typing in t equals max of whatever our current transition width value is, t, and we'll just hard code that in. We'll say 0.0001. So now if my transition width is set to 0 here and I slide across, you can see everything fully resolves, but we just start adding a little bit of an offset to it. I'm going to say 3 zeros and a 1 should do it for that. All right, so I'm going to set this back to our defaults like so. And here, actually, I can show you how we can update the actual gallery entry that we have. So if I have my gallery open and I have my transition gallery preset right here, I can just double click it and say set node information here. So if I tick this box and drag my wrangle in there and hit accept, that's all you got to do to update your preset. Now, if I drag this one in here, you can see that it has added that little epsilon that we added right there. You won't really see this in the rest of the lesson since I'm doing this in the future, but shouldn't really affect anything for most setups, but it's just something that I wanted to make sure was in there before we moved along. All right, so I'm just going to clean this up here. Let's close the gallery manager. I'm just going to delete this extra node, and let's give ourselves a little bit of space here. And now I'm going to just hit the Alt key and click on this little section here in the middle, the burger. And we're going to kind of flip it vertical like this. And then I'm going to just, without the Alt key press, tap it again so that we can flip it over to the side there. Just give us a little bit more real estate to look at our thing that we have here. So now that we have this, let's kind of do something cool with it. I'm going to go to frame 0 and we're going to set a keyframe on the position. And then I'm going to go to frame 240 and then let's bring our position all the way up to 1 so that we just have this nice animation that we can kind of scrub on our timeline like that. And then we can actually make this mask transition do something that looks a little bit interesting. What we could do here is maybe, let's say, bump up this geometry so it kind of rises up a little bit as this mask moves across it. So the way I can do that, I'll just throw down another wrangle after this one. So throw on a wrangle. And here we'll just raise it in Y. So we'll say at p.y plus equals f at mask times some multiplier we give it. So we'll create a parameter for that, chf, and we'll call it mult. And close that off and hit the little button so we get our slider here. And you can see if I just crank this multiplier up that it's lifting our geometry up a little bit like this. So that's pretty cool. And we can now, because we have this distance along this map attribute created here that's normalized, we can apply some noise to this and it'll actually help start to break up what our actual mask transition is doing over here. So let's add a little bit of noise. It's pretty easy. You just go up here and throw down a adjust float. So attribute adjust float right here. And what we can do is instead of adjusting P scale, we'll just adjust that map attribute that we've been working with. So let's visualize that. You can see we've got our map attribute. And what I want to do is multiply some noise into here. So you can see we're starting to add some noise into our transition. Now, if we go back here and scrub through our timeline, you can see that it's pretty crazy because the noise is really intense. You can see it is slightly moving from left to right, but it's a little bit too intense for what we're after. So we can go back to our adjust float and just change what the min and max values are of our noise. So let's say we only want to multiply our current map attribute by just a little bit of noise. We can just bring up this minimum value to some number that's very close to 1. Now, if I bring this all the way up to 1, it's going to have no effect whatsoever. But you can see if I just start to bring this down a little bit, it's starting to kind of creep into that map and break up that leading edge a little bit. So you can kind of play around with different values that work for you in a scenario like this. But now you can see that when we scrub, we sort of get this sort of noisy transition that we have here. And then we can kind of go down into our map transitioner here and further kind of direct it. We can actually make that be longer, more gradual, much more steep. And maybe what we can do is we can actually use this transition to create sort of a ripply effect to it. Because now right now it's just pretty linear. You can see that this slope is very basic feeling the way it's kind of coming across, but we could add a little bit of character to it by tweaking around this ramp. So let's maybe add some additional points. I'm just going to make the ramp a little bit bigger, maybe slide this all over, give ourselves a little bit more real estate. Here I'm going to maybe, let's say that once this gets up to this certain level, it's actually going to kind of sit at about 50%. So we're going to bring that down to about a value of 0.5 here. So its ending point is going to be 0.5, but here we can build in an overshoot. We can kind of have it zigzag back and forth a little bit to kind of create this rippling effect. So if we kind of push that back, you can kind of see that it's got a ripple going on in there. Now, I might just disable the map for a second so that we can kind of see it a little bit better. And here, I'm just going to select all these notches. So I'm clicking the first one, shift selecting the last one, and choosing the interpolation to B-spline. And you can kind of see that we're getting more of a ripply shape here. So let's actually add some more control points. I'm just going to have this ease a little bit on the front end. And then we're going to have the initial spike be pretty high. So I'm going to bring those bring a couple notches up here like this, and then we'll have it go down, up, and just kind of create a nice little sine wave looking spring decay type situation. Maybe make this more subtle like so. Yeah, something like that. And it's pretty abrupt, so maybe we can actually spread that transition width out a little bit. You can really see how you can actually, you're really starting to get the ability to art direct the way that something that almost looks simulated is being pushed across your geometry. So I'm gonna actually, maybe now let's reintroduce our noise and see how it looks with our noise. It's looking pretty cool. And now because this is just an attribute, we can do other things to it. We've got this map attribute that we're adjusting, we're adding noise to it. We could throw in an attribute blur and just sort of try to make this feel a little bit smoother. So instead of attribute blurring P, we're going to just attribute blur the map attribute. And you can see here we can actually totally just blur out that noise attribute, that map attribute, and get something a lot more chill like that. We could even have it smooth out the border points as well by unticking that. Being able to art direct and control what our map attribute looks like, and then being able to comb through it in a normalized way. This is just one slider, it's 2 keyframes, and it almost looks like a simulated effect, but it's not. It's just this simple art directable little transitioner that we made here. So this is a thing that I use all the time on my projects. I'm using it in all sorts of different tutorials. So the reason why I'm making this tutorial is so that I can just refer you to it when I'm using these Vex presets in other lessons that I create. Now, if you look at this example project that I have here, I'm just going to bring this over. You can see a couple other practical uses of this transitioner. So here in this example file, I've got kind of that transition that we just made happening here, more or less the same setup. Here, what I'm doing is I'm just creating a curve. I'm going to kind of check this out. Let's zoom into the curve. And here what I'm doing is I'm resampling it and giving it a curve view attribute. And then here in this node, what I've done is I've set my map to be equal to the curve view node. And here I'm just removing any point where the mask is less than a certain number. And you can see that this kind of creates like a carve effect for us. So this is like a simple example of how you could just reset a couple of attributes here and just use this mask attribute for something completely different. This is also another example of kind of why I like to leave this as a gallery preset. Instead of making an HDA, I prefer to keep this as like a Vex preset because I can just easily get in and hack around with it. I can change my curve view. I can change my map attribute to be some other attribute. I could just use the mask to just straight up delete points on the fly like so. Another example is sort of a KinFX like example. You can see here, this is something I kind of covered in my tree tutorial over on the Houdini School course that I made. Similar scenario, we're going to start with a line. We're going to resample the line so we get a few points along it, and then we're going to use the rig doctor and initialize transforms on those points. So basically we get a rig here. Then what I'm going to do is I'm going to use that curve view attribute that we, when we resample, we create the curve view attribute. I'm going to just use this transitioner to take our curve view, output a mask on it like so. And then we can use that in, say, a rig attribute wrangle right after here. We can say, use that to rotate our transforms on our KinFX rig to create this kind of unfolding spline example. I think I'm getting let's do labs reset viewport. Yeah, there we go. And you can see that this is one way that you could unroll a curve using KinFX, like so. And you can actually, in here, go to your transitioner and just sort of crank out the transition width to adjust how curly this is, adjust the easing on it, like so. And you can even apply this to a larger example. For here, I did an L system and went back to using the distance along geometry method here. So what I did was I selected this first start point right here at the bottom and measured the distance along geometry using that. And you can see that the output map that we get shows that attribute going from 0 to 1 as we move from the root to the tips of our branches. Feed that in through a rig doctor and then do the same thing right here. We're just using our same transition. And here we're just going to use our map attribute that we're creating as our map. And our rig attribute wrangle is going to be adjusting the scale and the rotation of all of our branches of our L system. Super easy, super modular, easy to hack. But yeah, I hope that you found this useful, and keep an eye out for more modular MFX modules in the future. Thanks for watching.